Let's understand what is elementary transformation. Okay, now with an example, I'll teach you what it is. Now when we talk about elementary transformation, see, the first discussion what we can do is how to do elementary and what is an elementary transformation. Okay, now the easiest way to understand is that when you have a matrix, suppose if you are going to change the row and column, or when you multiply to the row, multiply to the column, so what exactly are we going to do? Okay, now this is basically elementary transformation. Guys, it's as good as saying that it's an equation. Okay, now see, for an example, suppose when I say 2x plus y is equal to say 3, assume. Now, if I subtract y on both the sides, that means you are doing 2x plus y minus y cancels is equal to 3 minus y, correct? Now, what did we do here? We added, or you subtract or you add on both the sides, correct? That means when you have an equation, you do it on both the sides, correct? Simple logic. Suppose you have just an expression. In the sense, instead of saying 2x plus y is equal to 3, suppose I write 2x plus y. That's all. Okay. Now here, you add and subtract, correct? This is the common logic in math. The same thing you do for multiplication and division also, isn't it? Suppose when you have x by 2 plus y by 2 is equal to 3, suppose. You multiply 2 on both the sides, or you multiply and divide by 2, correct? Now here what you are doing, you are multiplying to every term of the equation. Make sense? Now in an elementary transformation of a matrix, this is the logic what we are going to do. Okay. Now you have a particular row or you have a particular column. We multiply to the entire row or you multiply to the entire column. When you multiply, you also have to divide. So this multiplication and division is going to go row wise, column wise. And when you do this, changes in the row and column, when you multiply, you have to divide outside. Or when you're dividing, you have to multiply outside. This is what we call as elementary transformation. Okay. Now, I'll show you with an example as to what is or how do we do elementary transformation. Okay. Just a simple example I'll take. Not exactly we are solving everything. Just a simple example as to how you can multiply and divide for a row, multiply and divide for a column. Okay, just a simple example. So now what we'll do, guys, very simple. Let's take a rectangular matrix. Suppose say I'll take matrix A, 1, 2, minus 3, minus 5, 1 by 7 and 10. Something like this. Now what we'll do, I'll show you how we can do the row transformation and all. Okay. Now the first type of row transformation what you can understand here is that exchange of the rows. That is, we can write R1 is exchanging with R2. So when you do the row exchange, matrix A becomes minus 5, 1 by 7 and 10, 1, 2, minus 3. Change in the row. Fair enough, this is one type of row transformation. Now, the same thing you can do for column also. You can change column 1 to column 2, column 2 to column 3, or however you want. Whatever you feel easier and comfortable and what is necessary for the problem, you guys can do that column or row transformation. The second type of transformation, what we can do. So, we can write that, okay, I'm going to take, see, every time when I take, I'm going to take the original matrix, okay, not the changed one. Fair enough. Now, what we'll do, we'll take R2 is equal to, say, okay, I'll do one thing. So, instead of taking division, I'll do multiplication. I'll say 7 times R2. You're just changing it. Now, what's going to happen? So, here matrix A becomes, see, you're doing only for R2, right? You're not changing, you're not even touching R1. So, keep the R1 as it is. 1, 2, minus 3. And look at this. So for this one, we are multiplying by 7. Correct? So you are going to get minus 35, 170. See, this becomes the second type of transformation where you are doing multiplication. Guys, you can also do division here. In the sense, I can also write R2 is equal to 1 by 2 R2. In the sense, you are changing the row and you are dividing every element by 2. You can either do multiplication or you can do division. You can do either one of them. Alright. So this is the second type of transformation what we can do. Now let's move into the third type of transformation. See, in the third type, let me write it here itself. So see, in the third type of transformation, what we'll do, what if I have to add or subtract 2 rows? Okay, along with the, with the second type property, whatever we did. In the sense, what if I tell you that I'm doing R2 is equal to R2 plus, let's say, 5 times of R1. So the second row is second row plus 5 times of R1, the first row. That means here, see what's going to happen. You'll get A is equal to, the first row you're not touching at all. So keep it 1, 2, minus 3. Keep it as it is. Now the second one is what? So now R2 is minus 5 plus 5 times of R1. So 5 times of R1. What is the value? Corresponding value you have to take. Because for minus 5, 1 is the corresponding column element. So we take the corresponding column element. So what do we do? Minus 5, which is R2 value. So this is R2. This is R1. Correct? You take minus 5 plus 5 times of 1. So we'll get minus 5 plus 5. The next one, 1 by 7 plus 10, 5 into 2. Next one is 10 plus of minus, so minus 15. So what do we get here? A is equal to 1, 2, minus 3, 0. Next 71 by 7 minus 5. Minus 5. Now guys, 3 types of transformations you just saw. One is exchange. Correct? So the exchange part is always given by this. This is the exchange part. Okay, the next one what you are looking at? You are looking at either multiplication or division. Correct? That's the second part. And the third part is what? So you are looking at summation. It's not just always summation. You can do minus also. You can do any of the plus and minus. In the sense, in general, if I have to write this, what you are going to get is that, in general, if I have to write this, then we can write Ri, you are exchanging it with Rj, or column I, you are exchanging this with column J. First type, okay, the first type of elementary transformation. Second type of elementary transformation is that you can do Ri is equal to some value lambda into Ri, or you can do 1 by lambda also, it depends. Same thing with column. So column I is equal to lambda into column J. Okay. Now the third type is Ri is equal to Ri plus lambda into Rj. Lambda can be plus, minus, any value. Or column I is equal to column I plus lambda into column J. So these are the 3 types of elementary transformation what is required. And these are the only types of transformation what you guys are going to learn in matrices. Okay. So with each type of transformation, how you can reduce the matrix, and with the help of this elementary transformation, we are going to find out the inverse of a matrix, which we are going to do in the next video.